Well, hello everybody and welcome back to Canal Sidings for another video. Apologies for the long time between videos, but I'm still recovering from all the problems throughout the year. But I have been doing quite a lot of things on and off, and hopefully over the next few days, maybe 1 week, maybe 2 weeks, there will be 3 or 4 videos arriving on different topics that I've been working on over that time. What those videos will be, I'll let you know when they come. I shall do them one at a time so that we don't end up with a video that runs for 2.5 hours, because I do tend to waffle on sometimes. Just before I go into that, I would like to say a very big thank you to all of my subscribers. There's about almost 1,200 of you now. I don't seem to have been losing subscribers over the time that I've not been producing videos. In fact, I've still been steadily picking them up. So I do thank you all for that. And I say thank you to all my long-standing subscribers, and a big welcome to all my new subscribers. So that's that over. Now, what this video is about is a continuation of my Arduino Signal project, which there have been, I think, a couple of videos on in the past. I'll put them into a playlist so that you can just watch them all again if you wish, or if you haven't seen them already, you can go back and watch them before you watch this one. But what I was talking about last time was the need for being able to vary the delay as to how long a signal that you have enabled the delay on will stay red or yellow before it goes back to green. And I was toying with many ideas of how to do it, but I've come up with what I think is the ideal way, and there will be a new version of the software which will be 1.4 beta, which I will leave a link to in the description underneath here. And there will be another readme file with that, which is going to explain to you how you change the delays. But I'll also show you a screenshot of me changing a delay, and we'll change it on the signal. If you remember, this signal is the one that has the delay enabled. None of the others do. So what we can do is we can go through the signals, we pass that one, and then we pass that one, and then we pass that one, and we reach this one, and now it will sit for a little while, and then it will gradually go back to green. Now, before we get into any more of that, I've had a bit of stick from people suggesting that delays are terrible and should never be allowed. Some people are more vociferous than others. Well, if you don't want them, I'm not forcing you to use them. They are an option within this software. So if you can do it without the delays and get the signals to operate the way you want, then fine. But my point has always been that when you come to the entrance to a fiddle yard, there will not be signals in that fiddle yard, and it will be a hidden section, one way or another. And the last signal will not have a next signal, or that signal won't have another next signal to control it. So the last signal has to be able to go back to green, otherwise you'll never get another train into the fiddle yard. And that is all the delay is for, situations like that. If you have a continuous run, an oval or a circuit that runs all around your room, then these signals will just follow the trains around, and you will never need a delay. So the delays are not something that I am saying you must use. If you have better ways of doing it that fit within what I've designed elsewhere, then please go ahead and use them. But from my point of view, I haven't come up with a better way. So I have built the delays in. Okay, so you now know what the delays are for. Again, another little idea of why I'm using delays. And as you can see, if I do this, we go and 1 and 2 and 3 and 4 and 5. Let's change back on 5. This one will change back on 5 seconds as well, because they are set for delays of 5 seconds. What I could do, and you'll see how we do this in a minute, I have now changed the delay for signal, for that signal, for the red of that signal, to 1 second. So after 1 second it goes back. The yellow is still on 5 and it goes back. I could change the yellow back to 1 as well. So there we go, 1 second and 1 second. Their timings are not perfect because it's down to the Arduino's time it takes to execute things. But as long as they're within the second, I think we're fine. Now you can set those delays anything from 1 to 60 seconds. So it could take 2 minutes before the signals will all clear, if that's what you want to do. As I say, please remember, if you don't like the delays, you don't have to use them. Okay, what we'll do now is we'll go on and I'll give you a screenshot and show you what I did to change those delays. And then we'll come back and we'll see that I have actually changed them. I will change them to longer delays so that you can see that it really does work. We'll put the yellow one back to 5 and we'll make the red one longer. And then we'll come back here and show you what's happening. Okay, so here we are at the PC screen. Excuse the running through ripple, but I'm doing this by pointing the camera at the PC screen. I'm fed up with throwing money away on screen capture software that doesn't work very well, and especially when you have to buy another copy for every PC. You find one works on one PC and then you get another copy of it, it won't work on another PC. So I have actually got fed up with screen capture software. I can't find a decent free one. I've tried a few and they all have problems. So I've given up with screen capture, which is one of the other reasons why I decided to stop doing my JMRI videos, if you remember. But anyway, that's another story. Here we are in the Arduino IDE, which is what you can see up here, and it's got the signal, the Signals Type A software loaded, and this is the serial monitor, which you get to by going Tools, Serial Monitor. Up here is where you can type commands, and here it's telling you just what you've got loaded and what your delays are set to. You've got signal 1 red delay, signal 1 yellow delay, signal 2 red delay, signal 2 yellow delay. And then down here it tells you there are some commands available which you can use to set the signal delays individually, and they will be saved in the Arduino's EEPROM so that they are there next time you start it up and every time. And the 4 commands are RD1, that's red delay 1, YD1, which is yellow delay 1, red delay 2, and yellow delay 2. For signals 1 and 2, for the time the red signal is on, but then the time it's at yellow, and then it goes to green, which of course doesn't need a delay because it stays there permanently. And the delays can be set from 1 to 60 seconds. I decided that 60 seconds was quite long enough for a model railway, and 1 second was probably shorter than anyone will ever need, so that's what I've chosen to do. If you should hear noises in the background, it'll be my son talking to the guy who's doing a bit of paint repair on one of his vehicles. My son's a bit of a vehicle fanatic, so just ignore any noises in the background. So what you do is, if you leave this cursor up here, you type in the commands. So if we go RD1 space and then put in the number of seconds we want the delay to be, well, it was 5, let's make it 10 seconds, and then we hit the enter key. And down here it tells you that it has actually set RD1 to 10 seconds. And then tells you all the values. So we've got RD1 at 10 seconds. Now the signal that I'm using is actually signal number 2 at the end. That's the one I'm playing with, and the one I've got set up to produce delays. So what we'll actually do is we'll do RD2 space 10 and enter that, and now RD2 is set to 10 seconds. And that is really all we need to do. It's all we need to know, and all this information will be in the README file that you can download at the same time that you download the code. So there we have it. What I'll do is we'll go back to the signals now, and we'll have a look at the lengthened red delay on that signal. Okay, we're back from the PC, back to where we were looking at, and we now have the delay for the red delay on this signal set to 10 seconds and the yellow delay set to back to 5. So let's go. Start, and 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. Not bad. And then there'll be 5 seconds on that. I'm not going to count those as well. But it does work. And because you can set them to anything you like, if you've got some reason for wanting a train to take a long time to get before you can send another train, all that sort of thing, you can have up to 60 seconds, as I say. And if you want longer than that, you can always, in the fiddle yard, have the ability to do that, which will set that signal permanently red until you release it, which will set that signal permanently red until you released it. So I consider 60 seconds is long enough. So what's my next step? Well, I also mentioned last time that I was looking at how to use these Arduinos to signal bidirectional tracks. As you know, these are for tracks where the trains run in one direction only. Apart from possibly shunting moves and things like that, which wouldn't use these signals anyway. So I've been thinking about that, and I did suggest that what I would probably need to do would be to possibly write another program in the Arduino, and that would be signals type B. As it turns out, I think that I am going to add the bidirectional running to this Arduino, and the way I favour doing it at the moment is that there will be a link that you can add that says set bidirectional running, and that will actually link the two signals in each Arduino together so that they will represent two signals that sit very close to one another on the same track but facing in opposite directions. Each one will have a sensor after it, just the way they do at the moment, one of these sensors. But because the train will pass over both sensors, one in the right direction and one in the wrong direction, we can use that to our advantage, and we can then force all the signals in the non-running direction at this moment to red, and then only signal the train through in the other direction with red, amber and green, if that's what we're going to do. So that's what I'm thinking about. Now bear in mind that there are very few single tracks that need multiple signals along their length. It's a bit of a waste of time unless you want to put multiple trains in there. It would be very useful, and I think the southern region do this. They often have an extra track, so I'm told, which is used for the incoming commuter track in the morning and the outgoing commuter track in the evening. So it doesn't actually use bidirectional running, it's set for running in one direction or the other. And of course then you do want to pack as many trains into that track as you can, just the way you pack as many trains into all the tracks, because the Southern Railway commuter times is manic. But that's not generally what we're going to be doing, but I will allow for that facility. But my expectation is this would just be a signal that signals that you're at the end of the bidirectional track, or the single track, and that you're running into a loop, or you're joining a normal two-way running or something like that. So that is what I'm going to be looking at next. I haven't actually written any code for that yet. It's still formulating, or some people might say festering, in my brain as to what the best way to go about doing it is. But once you've set the link for bidirectional signalling, then the two signals will be linked together. But that's the way we were going to use the Arduinos anyway. That's how I was thinking of doing it, without having by putting them into a separate Arduino and not being able to do the same, use the same Arduino for everything. It would be nice if there was only one piece of software and you set each signal, each Arduino up to do what you want, just the way you can here as choosing whether a signal has delay on it or not. It's entirely up to you whether you use that delay or not. So that is really the end of what I've got to say here. I expect to be back at some time with another edition of my signalling Arduinos video. I have got another Arduino project on the go, which I will be doing another video on as one of the set that I'm doing, but I can't actually really demonstrate it to you because, not to put too fine a point on it, I've blown up my Megapoints controller, so and I'm waiting for a replacement IC. It was pretty much my fault, and it was just stupidity really. But anyway, I've been waiting for a while, but I have written quite a lot of code for that, and it's quite an involved piece of code, so we will have a look at what that's all about. And there will probably be another video as an update to where I am with the modification of my Inglethwaite layout. You remember I'm going to build a different baseboard on one side of my room, and we're going to have bridges and foam baseboards and all sorts of styrofoam baseboards and all sorts of things like that. What I've decided is that to keep the weights of the baseboards down, the back scenes aren't going to be fixed to them. They are going to be separate, and the baseboards, when moved, will just leave the back scenes behind. So I'm going to build the back scenes before I start, and they're not just going to be pictures, they are actually going to be proper scenic back scenes, but only perhaps an inch deep, 25-30 millimeters deep, and they will just have buildings on which are just very low relief. And some of those buildings I've already got and built from the a range available at modelrailwayscenery.com. So we'll talk about where I am on that, how far I've got, which is actually, I have to say, not very far, in another video. And then there's also the possibility of a video on my points controller that Hugo and myself have been working on rather sporadically during this year for various reasons, as you know. But Hugo has redesigned it completely, I think twice now, and has come up with something that looks really good, should satisfy everybody's requirements as a point controller. It's not meant for anything else, it's meant to control points, or turnouts if you're in the States. And there is already a couple of videos for that, which I'll make sure are also in a playlist so that you can play them whenever you like. So until the next one, which I might decide to do something tomorrow or Wednesday. It's Monday today, the 21st. So 21st, where did you get that from? It is Monday the 17th of December today. And I may do another video tomorrow, I may not. I may see Hugo on Wednesday, in which case on Thursday I may do a video on the points. Although I might decide to just give you an update on the other layout as the next video anyway. But there you go. I hope you've all kept up with all your JMRI enthusiasts, who I sort of rather let down by saying I wasn't doing any more JMRI videos, because there was somebody doing it better than I was doing it, to be honest. And I did post a video link to John's video over at TSG Multimedia, and I hope you all went and had a look at that, and I hope you're all finding his videos at least as good as mine. I think they're infinitely better than mine, and the production quality he uses is infinitely above mine. Anyway, enough waffling. Thanks for watching, and hopefully I'll be back with a few more videos, well, another video or two anyway, before Christmas. So thanks for watching. Bye for now. Don't forget the link to the software here, if you want to play with the signals further, will be in the description. Bye.